going to start session 2, starting off with Daniel Davis with CASE.
So, hi guys. I'm Daniel, and I'm the lead researcher at CASE. For those of you who don't know CASE, these are some of the data about us. We've been growing really quickly. We're a technology consultancy. We've got an office in New York where it's kind of like a main office, and then we've got all other people working in North America, South America, and we've just opened one in Europe. We're comprised of architects, software engineers, people from facilities management, construction backgrounds, and we help people in the building industry. We help them with technology problems. So we help architects, engineers, owner-operators, people like that. We help them with their technology. We help them implement technology. And a lot of what we end up doing for these people is helping them with data problems that they have. So pretty much every project that CASE touches involves data in some way. And today I'll be discussing some of the ways that we've been using data with our clients, some of the ways that our clients have been using data, and some of the ways that we see data evolving in the AEC space going forward. So I'll just qualify this statement by showing you like 8 projects really quickly that I think exemplify CASE's use of data, and then I'll go and discuss a little bit of theory and then pull out one of these projects as a kind of case study to wrap things up. So we use data in kind of all the ways that you'd normally imagine data being used in the AEC industry. This project for NBBJ looking at how the topology or the space of a building changes the interactions of people within the building. A project for RTKL in China where we're looking at pulling up and surfacing data in this master plan. It's a master plan designed in SketchUp and Rhino and Grasshopper, and then we've developed this dashboard that's pulling out analytics about things like solar loading on the facade, program use within the building, how the buildings are matching developer targets. Stuff for Autodesk, doing energy analysis. Looking at post-occupancy studies. This is in the UN building, looking at how rooms are being used over time. And the slide's not going. And then a lot of our work, the data's kind of invisible in it. So we have lots of these like interesting visualizations that I'll be showing you today, but then a lot of what's happening is data's being used in the background on these projects. There's not really much to talk about or discuss visually. So this is a project in Louisiana called the Louisiana Sports Hall of Fame. It's got this really beautiful kind of curvaceous interior to it that's made out of 1,000 cast stone panels, and we developed the shop tickets for this. So to develop 1,000 panels, it requires a lot of data. There's not much to show for it other than these kind of weird drawings, but a lot of our projects, data is this kind of conduit through which we're doing our design. And again, in the similar sort of sense, this project for Hall Construction, it's an FM tool that's based on a tablet or in a web-based interface where they can look up components within the building and look at how they're using them. The SOM dashboard we developed, and I think Nicholas showed this earlier on, so I won't talk about it very much. Similar sort of thing that we've been developing internally, it's called the CASE Building Analytics Package, looking at kind of ERP and how we can pull that data out, surface types of buildings being used in CASE. This is a project we did for Stanhope, and in this case we're using data to manage and analyze bugs within a building. So using the Jira platform, looking at errors within our models, and then using this to do burn downs and stuff as we're coming up to CD and producing the final construction documents. And for RTKL, a similar kind of dashboard to the CASE Building Analytics dashboard that's surfacing the projects that RTKL has been working on. And this is for, like principals and managers of the firm. They can go to when they pitch a project, they can go and look up similar projects within their portfolio and draw out key statistics of these projects in the past. And this is like the final one of these like quick fire projects that I'll show, which is the case BIM hardware benchmarking tool. We're just still in beta on this one at the moment, but we're basically trying to look at how hardware configurations are changing or improving performance within computers and trying to deduct what is actually the important thing in developing a computer for a hardware, for a BIM solution. So this is the interface to that tool. But I think Case's use of data is not really particularly, or the fact that Case uses data in all of our projects is in and of itself not particularly remarkable. The use of data has been going on pretty much since architects have been able to draw, so at least since the Renaissance. And then even before that, when architecture was this kind of guild, the idea that what we were transforming or what we were sharing as architects was really this data or this information about how the building process went on. So at Case, we're not particularly interested in the data itself. We're really interested in what we can do with the data. And we're not really interested in the model itself. We're really interested in this building information, this information that we're inherently creating as we're doing our jobs as architects or as constructors or whatever. And so if I was to kind of characterize what's been happening in architecture in the recent history, I would say that most of our use of data has been about producing information about buildings. So if we're talking about building information modeling, we're talking about producing the information that's necessary to go and construct a building. But the real potential for data is this idea that we could take data and somehow turn it into some sort of knowledge, or we can deduct, or we can, in a constructivist sense, extrapolate some kind of knowledge or wisdom about what's actually going on within our buildings. And so the hope, I think, of big data, of any sort of data, is that there is some kind of information or knowledge within it. And the problem that we're having at the moment is that we're not really asking the right questions of our data, I don't think. And many instances you're seeing data being used in these projects where it'll be kind of these colorful diagrams of like a CFD analysis, and it's not about producing knowledge about the design process. It's about producing a defensible position on a pre-rationalized kind of solution. So I think asking the right questions of the data is like one of these kind of very essential parts, and I think it's something that we'll see more and more in the architecture industry, is people questioning and interrogating the data that they've already produced. If I was to conceptualize this kind of in my framework of how I kind of think about knowledge being generated, this is, I guess, a constructivist kind of philosophy based on like Donald Schoen and Nigel Cross. It would be that knowledge, as we're trying to generate it, is coming from us planning to carry out some action, conducting that action, observing what's happened, and then reflecting upon what that means. And that knowledge is really generated in the top of that circle, that it's in that reflection between what we plan to do and what we observed happening, that we have some kind of inference about what it is inside the world that we understand. And that when we look at where data is used in the architecture process, it's mostly used in the action. It's the thing that we use to do something, but it's not the thing that we use to maybe come and observe what we have done or to generate the knowledge about what it is that we have done. So I want to give like one example of where Cases use data to generate knowledge that's been particularly helpful to one of our clients. So this client, it's NBBJ. Andrew's going to be talking about them because he's from there later on, but he assures me that he doesn't actually, he's not familiar with this part of their work. So NBBJ, they were developing a Revit content library, and this is something that pretty much every architecture firm is trying to do. They've been trying to do it before they even had Revit. They've been trying to produce detailed libraries, and they've been trying to kind of codify what it is that they know, or what it is, the knowledge that's produced within their drawings. And so the way that a content library is typically developed is that you have all the big people at the architecture firm. They'll sit around and they'll argue about their kind of internal biases about what's good content and what's bad content. And it just turns into a disaster. And so what we did for NBBJ was, rather than trying to have these people debate what it is that they thought good content was, we took exceptional projects that NBBJ had worked on, and most of their projects are very good. We took the very best exemplary projects the NBBJ had worked on. We took the knowledge that was embedded within these projects, and we began to extract the best of this so that we could reuse it later down in the process. So we took 7 projects, which consisted of 49 models. There were 2,000 families used within these, and the families were used 500,000 times. And so we have this huge collection of data about what NBBJ is using and what they prefer to use. We're able to graph these and begin to look for the best content. So the most reused content, the lightest content, content that's matching these kind of very select criteria. And then basically we can go through each category of content and we can begin to filter it down. So we can start with, say, this is specialty equipment, starting with kind of 5,000 files, and then we're getting it down to about 400 different files. We then take these 400 files, we refine them, and we end up with this library of really, really good content. And this content isn't stuff that we've kind of just sat around and decided about. It's content that was this kind of tacit knowledge that NBBJ had latently inside their process, and that we've been able to surface it and formalize it in this way. And so they end up with this catalog of parts. They end up with their Revit specification document and their knowledge, their catalog of parts again. And these are kind of like, in this case, it's all the petition walls that NBBJ uses. And these are the exemplary, the best pieces of knowledge that NBBJ has been able to produce. And so if we think about where this fits into this diagram, it's really that NBBJ has been doing all of this action. They've been producing all these projects for years and years, and we've been able to observe what's happened using the data. We've been able to generate knowledge about what it is that's the best pieces of NBBJ's use, and then we've been able to plan for their future use by producing these documents that are articulating what content they should be using. And you can imagine down the line for NBBJ, it's been happening in the SOM dashboard, as you probably saw earlier today, that we can go through this cycle again. So we've produced this set of knowledge that NBBJ is using, and we can observe how they've used their best practices and then go and change those again as we begin to see NBBJ shift and how it is that they're practicing as architects. And so, yeah, that's my talk. Thank you.
I'm Randy Deutsch with the University of Illinois School of Architecture. I was given the opportunity a couple years ago to design a 500-room dormitory prototype that would be located eventually on every campus in the United States. And I worked with a very exciting team filled with R&D and strategy people, a lot of people in the data space. And what happened is I noticed before too long most of the conversations really revolved around what we can do with trying to capture data. Working with the likes of Google and Groupon and others, how can we capture the data in a way that was non-invasive? So the one approach is for those that have tried to hide a key in their backyard, you do so on these hollowed out rocks. And now we have these rocks that also have sensors and cameras hidden in them. And so that's one approach that we can take. I happen to know that most students don't own a clock. I teach an 8 a.m. class, and it's pretty unlikely this would ever happen. The other approach is the completely opposite one, and that's a very transparent one where we know the technology is there, capturing the data. And most importantly, to be non-invasive, you have to create a whole ecosystem that included when students entered the building, or they used the lobby, or they were in the social spaces, or even in their dorm rooms. When they were doing laundry, we capture the information from them in exchange for subsidizing their rent. And that was the whole idea. But the big lesson for me was meeting after meeting after meeting, nobody wanted to talk about the building. So as a practicing designer and architect, it never happened ever where we ever talked about the building. The building was incidental. And I thought in Capsule that really summarized where buildings were at, sort of echo a little bit what Shane was talking about in relation to the rest of the industry. So one of the things I want to look at right away is look at these three words, data-driven design, starting with the word data. And again, as Daniel just mentioned, you really want to go upstream. You want to use that data in a way. This is a flow chart. There's the pyramid, of course. You want to arrive in the end, if not at wisdom, with insights. Andrew Witt at Gary Technology the other day mentioned this to me. I love this building. Insight modeling is really what we're after now. Information in a way isn't even enough for us to capture what we need to capture. Many people feel that data is a commodity. It's something that is just there. It's not very exciting in and of itself. And isn't it really the algorithms that gather us on a Friday here to spend the day together? Unfortunately, the initials that make up that name, I think, send a different message. And Andrew, who will be speaking next, mentioned this wonderful line to me the other day, which I really think is part of the sympathies we have towards algorithms, which is they're doing a lot of wonderful things for us in terms of geometry and building performance as well as human performance. But in the end, we want to be able to monitor it and override it, have the opportunity to do so. Now, focusing on driven, there are companies, we're going to hear from Adidas this afternoon. There are companies that take it about data-driven design about as far as you can go. This company out of Germany that you can basically go to their website and available immediately are hospitals and other buildings you can just order and they'll ship them to your site, 12 at a time. But the more and more I talk to people about the driven nature, it's really enabled and informed that they're looking for. Or in some cases, it's not even those, but it's inspired. They won't admit to it. In the architecture space in particular, we don't like to talk about being inspired by things necessarily. We want to keep it very unsentimental. But a lot of times that is what we're after. I think there's a lot of cases where we're misusing the big data that we have available to us. So this whole idea that we're using smartphones to tell us where people are walking so we know where to place the front door. And this is something from the 60s that we've been doing, if not earlier than that, where we can just observe using these two things called our eyes instead of smartphones and other information through GPS and GIS, where we can just look at where people are walking. So instead of data dust, we just look at where the dust is. And even in the snow, we can look at where where the paths are. Also, we also have to separate the signal from the noise. And so the noise might occur where there might be a food truck that shows up at one end of the quad, and then we lay down a path, and that's misinformation, and so on. Finally, the last word, design. In the writing of my book that's going to come out next year, Data-Driven Design and Construction, it took me about 4 months to convince the publisher to include the word construction in the title. They really just like the sound of data-driven design, in part unbeknownst to them because it's been used in UX, user interface, and graphic design, and so on. It's been overused in other industries, and not so much in our own. But the reality is that we really can't even stop there. There's many others that are involved to the point where it's starting to look like a Fiona Apple album cover. So here what I'd like to do is touch on the state of the data, because I'm from Chicago. And Daniel Davis, for those that haven't seen it, Architect Magazine has a monthly column, and this month's column is on the wonderful subject of productivity in the AEC industry. So no presentation at a conference is complete without some reference to it. But here I'd really like to dwell for a moment on McKinsey's diagram showing where construction is. I think it was referred to a little bit earlier as an outlier. And I'd like to suggest that construction in relation to the other sectors, I know it's a little hard to see because it's small, but in relation to other sectors, the other sectors seem to think because of the amount of data they have available to them, the number of transactions that they have with people, they are more in the flow and they are enjoying themselves a lot more than we are currently. So I'd like to suggest, in the spirit of several other presentations at this point, that we think about this situation at a very large scale, blue sky scale as another experiment. So not so much an add-on to existing technology, but think about what we can do at the whole AECO industry level in terms of getting construction from that point right there back into the Petri dish for starters. And then after that, see what we can do in terms of experimentation, using our creativity and innovation that we're applying to technology to try to up the game a little bit so we can rejoin the party. This heat map is basically saying the same thing. So this line right here is construction. It's a little hard to find, not just because of the small font and because many of you are sitting near the rear, but also because construction is under the category of goods, not services. So I think what's going on here is we're misread, that we're providing a product. We're product designers just at a much larger scale. And again, this is from McKinsey's report on big data. And you want to get darker colors. Dark is associated with being healthier. This is anemic, and like the word anemic, if you look carefully, you can see AEC. That's one way to remember it. So we want to improve upon that. So what we really have is an image problem in AEC, and there's a double entendre going on there. So the first image problem is the fact that most of our data is tied up in images, as you just saw in the previous presentation. We have, blueprints going way back and Mylars and so on. We don't have enough words. We don't have enough numbers. We're starting to get some video and so on, audio as well in terms of our data sets. But we rely too much on image. But just as important is that we have an image problem in the way, you can see this in the McKinsey report, IBM's report, and others, the way our industry is perceived by the outside world is that we are not even an outlier. We're sort of a non-player. And we need to rejoin that Petri dish and improve that image. So one way we can do that is stop looking at what we're working on currently as an end in itself. We frequently will work on projects that begin and end, and we file them away. And they don't really speak to the other projects that we do. There are great efforts, as you just saw in Daniel's talk, in trying to get them to talk to each other and inform each other, but also an overlap when you go back to your offices on Monday to find opportunities, even within your own organizations as well as the teams you're working on, to find an overlap with others upstream and downstream from you in the design, construction, operations process. I love this Charles Eames sketch because on the upper left you can see sort of the blob where designers are most happily working, and the bimorphic form in the center, that's where clients really want to see their focus. And the other one with the hash through it is society as a whole, what their interests are. And where that overlap occurs is the place where designers can act with the most conviction and enthusiasm, where the three coexist. A couple insights so far from talking to about 50 or so folks out in the industry in the preparation for my book. And one is just the simple question of what is everyone using data for? This is, we're told frequently from our own career standpoint we should have an elevator speech just for ourselves. Likewise, as an analogy, we ought to just, on the tip of our tongue, understand why we're using data in the first place, not necessarily even on our own projects as a one-off, but understand as an industry as a whole how we can make use of it, look at it in a much larger scale. So there are many separate reasons why, many reasons why we're using, but the key one is to regain relevance in the eyes of owners and our clients. And just one real quick example, but it's a story in many versions that I've heard again and again. It's where a client comes to an architecture firm or an engineering firm, a contractor, and says, for example, that we have a problem, that we're bursting at the seams, we don't have enough space. And then an R&D team or a strategy team or a design team comes forward and says, well, we actually ran the numbers, we looked at your data, and guess what? You're actually under capacity. I could see the marketing principal of the firm kicking you under the table, your leg under the table, saying, don't say that because we'll be out of a job. This could be potential backlog. And so one of the things we need to do and look at, we need to look at data in terms of the culture. We also need to look at the data in terms of we come up with the data and then we keep on making the same selections, sometimes the same mistakes. Historically, we've relied on experience, knowledge, and judgment, and that's something where we still haven't proven our relevance in the eyes of owners, and data has an opportunity to help us. And we all know by leveraging data, it's going to help us to redefine what it means to be successful in our careers. To me, this may not surprise any of you, to me it's an incredible revelation because I map out everyone I talk to in preparation for my book and discover that to the extent that they are involved with data or data-driven, they really want to talk about intuition more and more. There's a convergence going on in our industry, and this is not anything you haven't seen before, whether it's the augmented reality and BIM with computational design. Some say there's no difference between the two in design and construction. Another one, though, I'd like to touch on just for a second is data viz and how we're using it more and more for analysis when we really do need to be able to use that information for others. So what are teams going to look like as we move forward? These are cross-functional teams to solve all the problems that we have. That question is going to be answered in part through education, university professors, and teaching and training, but it's also within our offices in the HR department and marketing in terms of keeping people happy where they are. The makeup of these teams is really changing, and it's radically different, but the important message there, many of you here are represented in these slides, is trying to find a way to represent the glue. It's not a manager, it's not a team leader, it's somehow finding a way to oversee the individual efforts so they can help look at the big picture and look upstream and downstream. And maybe it's just somebody as simple as an architect. Many of you have heard about a T-shaped individual where the vertical is the deep knowledge and the horizontal is the wide wingspan of having multiple interests. So you may have the technology depth, but we need someone who's able to schmooze, to communicate, and to interpret for other people what it is that you're working on so they really understand up and down because they're not here in the room with us today. We're using language that's very unusual, and we need to be able to communicate that to your grandmother, as Einstein said. We're talking about big data here, and nobody really seems to understand how big it is, and so we need to be able to make that clear that when we see a slide like this or an image like this on our monitors, just how big it is. And this really isn't about technology, like I said, it's about culture. It's about changing the culture and the environment we're in. And as Shane showed a moment ago, I'm gonna wrap up here, we're hearing more and more that technology isn't allowed to stay on the job site. But I think one of the things I'm finding that's very interesting, it's not the technology and the fear of privacy or security that really concerns everyone, it's the culture. It's that contractors don't want to look or be seen as architects. And that's really what's keeping, I think, the Google Glass from the job sites right now. So very quickly, take your data and be the storytellers and facilitators, tell good data stories. We need some more entrepreneurship in our industry. Identify problems that can be addressed specifically with data and a way of thinking about those problems to render them amenable to computational analysis. Data, as we know, is part of the process, whether you're aware of it or not, or others you work with are aware of it, so you might as well be aware of it. We should start asking questions that other people don't necessarily ask. And all the activities that we do today can be transformed into data, and it's always informing our designs. BIM has value, it's a database, and we should start acting as though it is, and understand how much data is available and how it can be of use. Thank you. Next up is Andrew Heumann with NBBJ.
I'm Andrew Heumann. I was thrilled to see Randy go through the possible list of names for what it is that we do, what kinds of people we are. I'm officially something like a leader of design computation for the firm, but even that feels clunky. NBBJ, if you don't know, is kind of a large international firm, about 780 people in a few continents. And we've been been using computation for a good while now. This talk is going to talk about the way that we're using computation to facilitate collaboration, in particular 3 kinds of collaboration. Collaboration between designers in the design process, that'll be kind of the bulk of it. Collaboration with our clients, and then collaboration, actually designing to facilitate collaboration between the end users of architecture. So looking at the process, the nature of architectural design is well known to be collaborative, and collaboration often looks a lot like this. It's a bunch of people operating face-to-face, sort of manipulating models together, working with sketch paper and pinned up precedent studies and so on. And architects are getting very good at working through a kind of technological apparatus for collaboration, which is this sort of central BIM model. And here I've chosen about the ugliest diagram I could find. And it's I think the problem with the BIM model, or one of the limitations of the BIM model, is that it's not seen as a place of creative collaboration. It's a place where people are learning the sort of technological mode by which you push and edit to a central model, and there's sort of a central space where all of the data is stored. But it's not really necessarily seen as a way that people are exchanging ideas and thoughts. It also, and I think this image reflects it, suffers a little bit from a sort of sex appeal problem. There's definitely a divide that I've seen in the industry between kind of the BIM folks and the computation folks, and I think we'll start to see that disappear. And when we're working with computation, and when I say computation at NBBJ, historically it's been a lot of Grasshopper, but increasingly we're relying on tools like Dynamo and Python scripting, .NET development, and things like that. But the nature of these visual scripting platforms in particular is that there are not really established standards for how to document and organize them. So, this is a tool that I built, and even I probably couldn't go in and edit it today. I don't really know what's going on there. It's kind of a mess. There are a lot of dead ends. And if someone else were to try to hack into this, it would take a huge amount of effort to just get in there. So I see kind of a big collaboration problem around design computation. This is incidentally just the output of that algorithm. And I'll come back to this because view is kind of a theme of this talk. This was a tool that was used to analyze the views of particular building landmarks and scenic landmarks from master plan development in Bellevue, Washington. I was able to use this tool to generate graphics that we could talk about with the design team and make design changes. But the nature of this was such that feedback loop was, maybe one tweak or two in order to kind of go through the step of optimization based on this information, and I'd like to see that feedback loop continue to tighten. The other thing I'll point out about this is that a big component of the way NBBJ is thinking about computation is trying to look at human factors of experience and ways that computation can help speak to that, to really inform our intuitions about, what views are you getting from this floor of this building and this side. So the way that we're tackling some of the challenges around collaborating through parametric platforms, there are 4 major things. We're attacking it through training, through file management and best practices, through knowledge sharing, and this is something that's very, very early in the way that we're using it, but trying to tackle it through multi-user parametric modeling. Training, this is a scene from one of our sort of typical weekly training sessions. We attack training from a bottom-up and a top-down approach simultaneously. Top-down being kind of project-focused work. We do project ignitions, which are week-long entire project team training sessions with a computational leader to try to both get everybody up to a certain level of competency and to develop specific tools for that project that can be used moving forward. And then we also have ongoing sort of bottom-up training where every week or two we'll have a training session with a rotating instructor where somebody shows a particular topic, how to do solar analysis, or how to do a view analysis like the one that I showed. And what we've been realizing too, a big insight from trying to do training, is that there's value in a bunch of different levels of competency, and we're trying to raise up literally everyone in the firm to this first level of being a thinker, having a real understanding of capabilities of the tools and ways of thinking about problems, this is actually a huge barrier. And what we found is really productive is getting people in these training meetings. They don't necessarily have to be hands-on coding in Grasshopper or Python. They just have to be a part of the conversation so that when my 30-year veteran architect who knows how to design any parking structure in any site sits down with a computational leader, some of that insight can be translated into a tool that we can reuse. And we've also found that as these levels of expertise grow, once you get to the level where you can start to hack into the tools that get handed to you, the rest is kind of a breeze. It sort of happens organically, and our designers are rapidly growing from being able to make a few tweaks in order to adapt a tool to building their own tools from scratch. When it comes to best practices, we're employing sort of standard template files as deployment with our Grasshopper, and this is designed to kind of encourage best practices around documenting a description of your tools and instructions on how to use it, as well as a number of scripts that facilitate additional information on top of that. So one of the scripts is harvesting metadata from the file to tell you who wrote it and what dependencies it has, so you avoid opening it up and not having the appropriate plugins. Another tool is one to automatically color code groups in a definition according to a prefix, and this I bring up because it grew out of a discussion that I had with some folks from Thornton Tomasetti in San Francisco back in November, where they were showing their system for color coding groups, and I wrote a little script that would look at the name of a group in order to automatically color code it. So this may not look significantly better organized than the last Grasshopper definition I showed, but I think it represents an improvement, and there are lots of arguments about how these should be encapsulated or organized. But it's broken down by functions so that the user that wants to hack at this can figure out where certain functions are happening, and the user that doesn't can identify where actions need to happen, where are the buttons I need to press in order to just make this tool do the thing that it's designed to do. So we're always oscillating between the kind of project-specific dynamic tool and the one that is kind of packaged and ready for use. And what that's made possible is handing off, say, my view analysis tool, which that was another capture of the same tool, and I have to spend maybe 15 minutes showing a project team how to use it, and then they're not only applying it to their own design projects, but adapting it and changing the way that it functions and suggesting changes that can get folded back into the same tool. Another consequence of the kind of standard templates that we're using is that we can use the same sort of metadata harvesting across an entire library of tools. So this is an online portal we're using to document our computational work, and it can scrape a folder of, say, Grasshopper definitions and gather their author, their descriptions, and so on. Sort of like, it's almost akin to a Grasshopper version of some of these analytics, like BIM analytics that have been shown by other presenters. And this makes it easy for not only designers to say, what are the tools that are available to me, but also people who are not going to be using Grasshopper themselves to reach out and say, what are our capabilities? What can I reasonably ask somebody to do in 5 minutes or an hour or a day? One last piece of sort of infrastructural innovation is a plugin that gathers Grasshopper user objects and Grasshopper plugins from a central repository and automatically installs them on user computers so that we can keep everybody up to date and also push new tools that are well encapsulated to all users at once. And this gets to the last item of sort of multi-user collaboration, and I think we're not quite here to the level of clarity that's shown in this diagram, where you have a handful of people, each of whom is designing some component of a process, but I think this is the direction that we need to go. I think we have a lot to learn, and actually Daniel Davis's thesis on sort of the relationship between design and software development was a big inspiration for me in this thinking, that really we have to think about setting up scripts and models wholly collaboratively, and maybe it's wrong to indicate that all of these components are scripts. Maybe some of them are manually modeled geometry, but all of these things should be working together in tandem. To hop into kind of the way that we're applying this as a way to interact with clients. So this is a tool that we built it evolved out of one of these ignition processes where we had a sort of master planning project, and we wanted to set up a dynamic master plan tool we could use with the client. And it's evolved, and if you could just trigger the video. It's fairly simple. The computation happening here is nothing advanced, but it's a tool that we can use live in meetings to study scenarios and represent things dynamically, and also as a kind of paper doll where we can start to test programmatic sizes across the master plan. In this phase, it was being used to study the placement of anchor programs in this master plan. And so it becomes a very fluid way to both depict and analyze scenarios on the fly with clients. It was quick to sort of add a new scenario and start modifying it on the fly. And it's a great way to kind of get client buy-in on the process, make them feel like they're involved, but also to communicate to them the constraints on the problem. So if they say that they want it to be 9,000 square feet, but then they sketch something that's enormous, the tool will indicate to them that, this is over by a certain amount. This one's another video. We're thinking a lot about, a design environment with sort of integrated analysis. So this is a tool that we built for a sort of small developer office building in Seattle to sort of quickly test iterations. But the parametric model itself is not the thing so much of interest. It's fairly simple. But what's of interest is a kind of overlay of data where we're trying to set up these design environments where information is provided to designer and stakeholder alike about how different design variations are functioning from different standpoints. And this shows yet another evolution of this view tool where now it's just set up as kind of a design overlay on the top of a design model. So as design is changing, we can see the impact that has on, say, solar energy impact or view analysis. The last piece of this, and this is where the integration with sort of the client is, I think, pretty interesting and new, is that we were able to convince our developer client to share with us their pro forma, which, if you're not familiar, kind of a spreadsheet cost model that shows them ultimately how much rent they're going to need to charge based on design. And we were able to live update this pro forma based on the variable model. And it's this idea of putting value and cost on the same page. A typical pro forma has no field for the value of design. It only translates into rent. And trying to use it as a communication tool where you're seeing value and you're seeing cost at exactly the same time allows for a much better sort of client design decision-making process. Finally, to wrap up with a few examples of kind of using computation to enable collaborative spaces. We've been very interested, again, in looking at sort of human factors. And this is a quick video used to demonstrate a tool that studies visibility in space. The video goes a little slow. I might click through it a little bit. But essentially, it's looking at the space that's visible from any point in a floor plan to build up a kind of heat map. I think, actually, I'll skip over this one because I see I'm a little low on time. And the output of this tool is something like this, where you can get a sort of color-coded heat map of how much space is visible from any point. Now, that in itself is kind of interesting information to a designer, and it's a way of confirming intuitions about what design variations are going to do to a space. So if you take out the central row of offices, what does that do to the sort of visual space? And this is a different way of visualizing it than simple 3D. But there's a second order analysis that can be taken on top of how much is visible from a space, which is how complex is the sort of visibility network, or the sort of, there's a term, visual mean depth, which is a measure coming out of the space syntax group based in London that essentially can correlate how complex it is for you to see from point to point to point in any given space, connecting it with straight lines, essentially, which is a measure which is highly correlated with the capacity of certain organizations to generate new collaborative relationships. And one final project example, also again oriented around view. This is our headquarters for Samsung in San Jose. And we were interested in the design of this central courtyard space and how it would facilitate visual connections between floors. So the idea behind a sort of fully glazed central courtyard, can you start the video? Is that there would be sort of visual connections, not just to people on the same floor, but on different floors as well. So we set up a kind of simple simulation model that would track where people would go over the course of a day, but also study the visual connections between those people. So blue lines indicate visual connections on the same floor, and red lines are showing the impact of this sort of central glazed-in courtyard for creating visual connections between floors. So it's interesting because I think a lot of analysis gets tied to specific numeric metrics. And here we're trying to get at ways of using computation to address some of the more qualitative metrics that might be associated with the design of space. And that's it.
Last up is Zach Flanders with BNIM.
I want to thank TT for inviting me today. This is my first technology symposium, and very excited about what I'm hearing about, especially the conversations about what are we using technology for? Is it producing better outcomes? So my talk is called Crowdsource Cities, and I'm going to talk about some of the technology that we use in planning, but primarily it's about how do we engage people. Because I'm seeing that the biggest barrier to producing better cities, and when I say better cities, I mean better cities for people, healthier cities, more equal cities, more sustainable cities, is not how do we build it, but how do we convince our elected officials that it's worth it? How do we convince our developers that people want it and they'll pay for it? And how do we give people a voice to say that they want it and to have a hand in creating it? So crowdsource cities, here we go. What is crowdsource urbanism? I think it's driven by a bunch of different trends. First off, there are more people moving to cities, especially in Midwest cities, and they want to have genuine ways to impact the built environment. In the Midwest, cities have been emptying out. Over the 50s, the 60s, the 70s, the 80s, and even the first half of the aughts, people were leaving. And what was left was kind of an abandoned industrial downtown area. Now people are coming back and they want to shape their cities that they're living in. They want it to be greener, they want it to be healthier, more sustainable, and they want to have a hand in doing it. So this is happening, and it's made possible by technology. I guess the best way to explain crowdsource urbanism is with a story. So a colleague and I were sitting around on our lunch break, and we saw this TED Talk about this guy that was doing this Build a Better Block project. And what he did is he just organized a bunch of people, and they all showed up, and they transformed a city block for a day using temporary materials like duct tape and crates. And so we said, hey, this would be a great idea to do in Kansas City. So we had just completed this plan for Grand Boulevard, which is a large 7-lane arterial through downtown Kansas City, and it currently operates almost as a highway. People go 70 miles per hour down this thing. The posted speed limit is 30. So we had this great plan for reducing it down to 3 lanes, including a double cycle track, expanded public space, and for a variety of reasons, it ended up sitting on the shelf. So we said, hey, this is a great opportunity to breathe some life into this plan. And so we picked out what I think is the most desolate block in the entire city, an entire block of parking, and on the other side, every single building was vacant. And so we said, great, this is the perfect opportunity to showcase how infrastructure can change a hollowed out downtown city like the one we were living in. And so we spent some minutes in SketchUp and just laid out the basics of what was included in the plan, the cycle track, the expanded public realm, the street parking, reducing lanes, the road diet. And we went out onto the web and we said, hey, we're going to do this. And we committed to it, even though we had no idea at the time how much work that was going to entail. And the good thing is people really responded to it. and they started sharing it on social media. We used a crowdfunding website to raise the money to get the permits and the insurance that we needed, and it really took off. And so how was this crowdsourced? Well, we basically, all we did was that SketchUp model, and then people started volunteering, hey, I'd like to redo your plan this way. So this landscape architect redid our plan, made it better. We had students showing up and say, hey, we would like to design a portion of the block. We said, sure. We had artists come in and say, hey, can we be a part of this? We'll just show up with our art and we'll figure out what to do. We said, sure. We had somebody wanting to donate a piano. We had urban farmers coming and say, hey, can we plant trees and a fruit forest on your street? And we said, of course. And another guy said, hey, I have a beer cart. Can I come and serve beer? And we said, do you have the appropriate permits? And he said, yes. And we said, absolutely. So it just it was the easiest project ever PM'd because people just volunteered and showed up and made it whatever it could be. So I mentioned that we used crowdfunding to get the small amount of money that we needed to pull this off, and almost everything else was donated. And by the way, this is through our Downtown Neighborhood Association. This isn't necessarily through my work with BNIM, although they did give me time to work on this, so they do deserve some credit. But this was just downtown neighbors saying, hey, we want to do this. Let's get together. Let's do it. And we did. So we showed up, and we transformed the street for 24 hours. We used these straw wattles that are used for erosion control to remake the curbs. We had 500 rose bushes donated, all with real thorns. We had these trees brought in that were on the way to a different job site, and we just said, hey, can you drop them off here for a couple hours, and then we'll load them back up? And they said, sure. So that's what it looked like, and we learned a lot. We didn't have to do a traffic study to realize that, this was during rush hour of the busiest night of the month, and there was no problem with level of service, even dropping down from 7 to 3 lanes. Crosswalks, I had never seen a car stop for a pedestrian on Grand Boulevard before, but suddenly we just put in these duct tape crosswalks and people started stopping. And buses, and there was concern with the city that buses and bikes couldn't work together. Well, we showed that it could. And people lingered for a long time. In fact, the tango group went through at about 2 in the morning and was like, wow, what is this? And started playing the piano and dancing on the street at night. And this is somewhere that would not be perceived as safe before. Retail, we had some pop-up shops, and they were able to do some brisk business. And it was easier than you think. We just showed up, we just put all this stuff on the street. We got this bus stop donated by the Metro, and some people started waiting there for their bus. And we said, no, this is just temporary. This is just an installation. The bus isn't coming, I'm sorry. And they just looked at us like we're crazy and said, what do you mean? It says the Metro right there. I can read it. And we were like, okay. And then a few minutes later, a bus showed up, and they got on. So the Metro was able to incorporate this new bus stop into their route, no problem. So there's just some more pictures from the day. People really had a good time. But so what? So we transformed one street for a period of 24 hours. And I think this makes the point that there are people that are living downtown now that weren't there before, and this was our way to advocate for better cities. It was our way to say, hey, we are here, this is what we want. It was our way to advocate and give people the will to do it. So there's 4 pieces of technology that I believe are driving this. And I'm going to go through them, and then I'm going to have a call to action at the end. So number 1 is the World Wide Web. And I know what you're thinking, whoa, this guy is cutting edge. But when you think about it, this is relatively new compared to how long we've been living in cities. For the millennia that humans have been living in cities, we haven't had a change this big since the printing press. And I studied history. If you want to talk about the big change that the printing press brought in cities, I'm available later. But this is a revolutionary ability to distribute content without gatekeepers. And how is this changing cities? I have a couple examples. One is that it's giving voice to ordinary people about what they want in their city. And this is a very popular blog called Urban Review St. Louis, and it's this urban planner who writes what are essentially movie reviews for public spaces. And it's very entertaining, very popular. He also happens to be in a wheelchair, so he blogs about every single obstacle that he encounters where somebody has, done like in the photo here and put a light pole in the middle of the sidewalk, and has basically forced Public Works to follow his blog and follow him around and just fix things that he points out on his blog. So it's giving a voice to people, and it's facilitating the exchange of ideas at a pace that we have never seen before. So for example, with bike infrastructure, it's just amazing how there are experiments happening in cities around the world, and they're being picked up and replicated. This is a video of a cycle intersection, improved cycle intersection, adapted from the Dutch system of cycling intersections brought to a U.S. city and how it could work, made by a student, and I'm really interested in mocking this up in case this could be the next Better Block project. Number 2, social media. So this is the second big technology that is changing the cities. So 2 sites I want to talk about. Nextdoor is a private, we all know about Facebook, Twitter, etc. Nextdoor is a private social network for neighborhoods that I think is facilitating this increasing political awareness and civic engagement at the neighborhood level that is leading to these changes. And MindMixer is a service that cities can use to encourage their residents to create ideas together and with an audience, with the elected officials. And so I'm running low on time, so I'm totally going to skip this case study. I'm just going to mention that we went to Tuscaloosa after they had a devastating tornado. Actually, we're invited to submit for doing their master plan on Twitter. We did all the social media stuff, and it was amazing the ideas and the conversation that happened on the site that we set up. And people really know what they're talking about. People aren't, we like to think of ourselves as the all-knowing expert, but in fact, a lot of times people know what they want and what they need in their neighborhoods better than we do. And sometimes it's good just to let people talk and to listen. And this is what people said. And it was high-level conversation about the design of their city. And people showed up to the public meetings because they were already engaged online. Skip some of this stuff. The entire plan was printed in the newspaper too, so we can't forget old media. And now they're building it, and now the elected officials have committed publicly to do it, and they've had their groundbreaking, and they're building parts of the city walk, which was one of the major components of the plan. Third is crowdfunding. We all know about Kickstarter. There are other crowdfunding specifically for civic projects. This is what we use to fund the Better Block. We also use this to fund new sidewalks in our neighborhood. And the one I'm really excited about is Fundrise, which instead of getting a t-shirt or a knick-knack for giving your money for a project, you actually can become a small equity owner of a real estate project in your neighborhood. My concern about crowdfunding is that it will replace traditional revenue generation sources for cities and could equal more inequality. But there are exciting opportunities with crowdfunding. So this is my fourth, and my call to action is free and easy to use apps. This is the future of crowdsource cities. So right now there are a lot of open source software. For example, this is QGIS. We use it quite a bit in the office. SketchUp is a free software that people can use to mock up things. So it's already lowering the barrier by the fact that it's free, which allows more people to have a say in what they want their cities to look like. Open data, this is OpenStreetMap. And Bootsy, Shane mentioned Google self-driving cars. Well, Tesla has committed to coming out with a self-driving car ahead of Google based on the data from OpenStreetMap. And I think it's incredibly important, this mapping information in the future. It's going to transform industries. And if you're not familiar with OpenStreetMap, you should check it out because there's data there that you can use in your projects. And it's important, I love Google, I have an Android, but it's important that one company does not have a monopoly on this important resource for the future. So that's already lowering the barrier for everyday people to say what they want in their cities, but we can go further, and we should go further. And this is an example of some very easy to use web apps. For example, Street Mix, where you can put in the dimensions of the street out front of your house and play around with, you know, how wide does the drive lane need to be? Can we put bike lanes? Can we put a median? Can we expand the sidewalks? And people can have a real say, and then, you know, email that to their elected official. Another one is Shareabouts, which is this great company called Open Plans. It does all open source software. And this is an example in Chicago where they asked people, here are the existing bus stops in blue. Where should the future bus stops go? And we saw the example of the data approach to that, and this is kind of the people approach to that, of people saying, hey, I'd really love to stop here, and you can start to see where they'll start to accumulate. So that's my call to action, I think, as technologists in the AEC industry. We should focus on not only how do we get data and information to work better within the industry, but how can we bring other people from outside, everyday people, into the process so that they can have a say in what their environment looks like, and so we can have better cities, which are crowdsourced cities. Thank you.
We have time for a couple questions. Again, the mics are up here in front before we break for lunch.
Andrew, this is a question for you. How do you see, is there a possibility for visual graphic interfaces that do programming to interface with something like a GitHub or some kind of community that allows people to sort of take these codes, see what the changes are, and see who's essentially rewriting it, editing it, or improving it? Yeah, if you could speak a little to that.
I think that's actually a super insightful question and something that we're actively thinking about and even working on a little bit. We're trying to port some of our toolkit development over to GitHub itself. I think the technical barrier, and this is a geeky point, but is the lack of a merge diff tool, a way to actually compare the binary Grasshopper files, and the Grasshopper SDK will let you look at those differences, but to be able to figure out what those differences mean in a graphical way that a designer can understand is, I think, the missing link in that process. So maybe somebody at the hackathon can make that their project. I don't know.
While you guys are coming up with another question, I've got one. This is for the whole panel. We agree with the statement that buildings are fundamentally about data. If not, please chime in. By separating a subject from the integrated process of design and construction, do we risk fetishizing data? Is it artificial to separate discussions of data from other sectors and other subjects? And does data in the AEC industry deserve or demand its own platform?
Yeah, I guess there is like a tendency to fetishize data. Yeah, I don't know.
I think that actually the diagram, the sort of pyramid diagram that you showed, Daniel, gets at my attitude towards it too, which is that, you know, data is just kind of the base layer, and certainly from a particular perspective, you could understand everything that composes a building as data, and certainly often we do that. But I think that's only one layer, and I really appreciated when Shane was speaking earlier the continued insistence on experience. And I think, you know, that's what at least at NBBJ we're trying to get at. What's the intersection of data and experience? Trying to understand not just how buildings perform through data and how buildings are constructed through data and conceived through data, but how ultimately they are experienced and what the data during the design phase says about that actual experience.
I think for data to be useful, it has to make the process more efficient. We need to build better buildings cheaper and faster with less human cost in terms of headaches and hours poured into them. And if data can do that, then I think it will become central to the design of buildings. And I like the graph where it was the high expectations and then the dashed hopes, then the slow rise towards productivity plateau. And I'm not an expert in building data, but it seems to me like we're somewhere between the high expectations and the dashed hopes, and then we will have a long way back to climb. If anybody disagrees with that, feel free to share.
Mustafa.
So I have a question for Zach. When you did that crowdsourcing, how much did you get from experts? Like how much data came? Like did you get some real urban designers or some designers or some architects being part of that movement, or how much you get from like normal people?
I find on the like the Mind Mixer, for example, in Tuscaloosa, yeah, there are some planners that will submit ideas, but for the most part, I think professionals are so tired of thinking about at the end of the day that they don't want to log on and contribute to a competitor's project, unless it is in their own neighborhood. So I think it really was majority everyday folks that were submitting ideas. As far as the Grand Boulevard, I mean, yeah, we had students from the design school, and we had folks in the office working on it, kind of setting up the framework for how it would all work, but it was big blank patches on the map where people just filled in and did whatever they want in those areas.
So it comes to my next question, if I can ask next question, because we have a really similar stuff here happening in New York. I don't know if you guys know about Beta New York, but they are really a group that you should definitely check, and they are civic hackers. And I started going to their civic hack nights, and what I noticed that there was no city planner, no architect, no engineer there. And it was kind of a question of like, if you are civic hackers talking about the cities, why you don't have people that really designing the cities, sort of. And now my next question is, what do you guys think we should do as an industry? Do we need to go there or not? Maybe that's the first question. And if we do need, which I think yes, like what should we do in that regard?
I guess I'll answer the second one first. I think it's beneficial to incorporate people in the design process from the very beginning, ask people what they want first, because I think you're going to get better ownership. And I was thinking about the image problem that Randy brought up. One way to communicate the value that we bring as an industry is to encourage people to participate in the decision-making process so they see how it works, they see how complicated it is, and they're brought along for the ride. And I think they'll place bigger value on what we do as an industry, and we'll grow as an industry because people will value what we do. What was the first question? Okay.
So we have a couple people want to speak. I just want to say, going back again to the 1960s, we had participatory design. When you think of all the great San Francisco architects, Charles Moore and so on, Michael Piatuk, David Baker, who participate with lay people out in the community, and the designers serve as refiners of that open source information. I think you're next, and then Robert.
Yeah, Mustafa's second question basically covered my question, but I'm just going to comment that coming from Midwest, I'm also another witness that these actually improve the cities and actually make the cities more exciting. Chicago was not one of the top 5 most competitive cities before Rahm Emanuel, and then before he introduced the open data portal for the city. And it's actually weird because where I'm originally from, we also blocked the printing press for 200 plus years. So it's a whole like a shift in paradigm for to see the improvement. But is a question like basically the profit that any of us want to bring to the table to case, for example, Daniel Davis wants to make his company profitable by making the architects profitable. But all these people who attend to like meetups, they don't care enough about it, right? They just want to live in better places. They just want to have better experience. Just like a client wants to have a better experience when they build their headquarters. So it's all just like a very fluid and really hard to draw lines in between what's going on in a civic hacking night and what's going on in a design collaboration kickoff. It's just like amazing, but really different motivations behind them. So, another question.
Thanks.
Yeah, hi, Robert Mincarini. I'm Principal Chief Technology Officer and Practice Area Leader of Design Technologies at Array Architects, where we specialize in healthcare and hospitals. And we sort of see two worlds where when we're talking with the leaders, the business leaders of the hospitals, they have a lot of the analytical skills to do something with data. They do a lot with data. When we're talking with the facilities folks, much less so. It's much more traditional methods based on experience and empirical uses of data. Randy, in your research about your book, what did you see? Do you see a lot of architects that have these analytical skills, and are they connecting and working with their clients, and are they leveraging that into business models that improve their business, or is it just, is really anything happening out there?
Yeah, it's a great question. I hope everybody heard that. I think the simple answer is it is happening in terms of business improvement for their clients. What we need to do a better job of is telling that story and being able to communicate what we're capable of doing. I'm not sure that's the same thing, though, as carrying on from design to construction to operations. I still see a disconnect between construction operations, that we're not able to take the great work and great data that we're capturing and analyzing early on into that last phase. There's certainly been a lot written and talked about through other conferences and a recent book through facility management and BIM in recent years, but we haven't made that leap. So there's still a gap. Part of that has to do with interoperability and understanding how they're going to utilize the data. Part of it's culture. Owners just really needing to understand how they can tie in with what we've come up with early on. They need to be present earlier on in the process as well for what we're working on to have an impact later on.
Yeah, I'll just add to that I think there's a lot of really sophisticated building owners out there. If you look at companies like, say, what Disney's doing with their parks and the way that they're gathering data about, they've got this magic band that they're gathering location data and they're correlating that with purchase behavior. And we're seeing companies like Target tracking people using Wi-Fi and correlating that with the mood of the person based on webcam data, which is really scary and stuff. But there's such a strong business case for the facility owners to be using data. I think that they're going to be actually the drivers of this change, and that whether or not architects hand off their data to the facility management, it's not really important. They can generate it some other way. So I think there is going to be more and more this push for it, and there's an opportunity for architects to supply it, but whether or not they're part of that picture is up to them.
Thank you.
Just a quick thought. I just thought of, it made me think of the Toyota model where even the lowest person on the production chain can stop it at any moment. I'm just wondering if facilities people if they can think of a way that data could be incorporated or used better, maybe incorporating them into the process.
It's actually interesting that you mentioned that, lean, the Toyota model and Six Sigma and so forth. In healthcare practice and in our business, healthcare designers, we use a lot of those processes, and hospitals use a lot of those processes, because constantly trying to make things more efficient. But there definitely are different groups within the industry, within the healthcare industry, some that take advantage of it, some that don't. And I just noticed from my own empirical observations, facilities folks are way behind in actually doing those things. You have some leaders, Sutter Health and Geisinger and so forth, who have a lot of this talent on staff to do things, see it in other facilities at all. You'll see it in retail. You mentioned Target and so forth, but you don't see it in spec office buildings. It's not going to happen there.
But it is a blue ocean, and there's huge opportunity there for those that are
Exactly,
interested. Great. One last question, and then we're going to break for lunch.
So I just wanted to steer the conversation back to crowdsourcing. I'm a big fan personally of the crowdsourcing, and I was just curious, just because Kickstarter and all the small projects that took off and it was such a big success, but I don't think it was very successful with larger projects, especially architectural city interventions. Do you think it's possible that maybe one day we're going to be able to, we all paying taxes, maybe there is a way to crowdfund bigger projects in the city where part of the money is actually directed from our taxes, and is there a way that legislation level will be able to make those decisions and based on data coming from people on the neighborhood level, and we don't really have to pay out an extra money out of our pockets, but maybe it's all directed from the budget pool, and we just get to say where that money goes to this project. You think there's a value in that?
So our city did a crowdsourced city budget where they just opened it up and asked anybody to comment on it. So I think that's a definite possibility. You're right that I haven't seen any crowdfunding have a real impact on any large infrastructure projects. And I think it's a danger to rely on crowdfunding, because if cities see that as a substitute for other revenue generation for provision of services and infrastructure, for example, if they lower taxes for everybody and rely on crowdfunding, you're going to see only the parts of the city that can pay for it have things like sidewalks and transit service that are absolutely essential to people being healthy and getting the jobs and having opportunities. So I worry about crowdfunding taking on too much of that role. But in terms of funding, a bike share station or a sidewalk, or I've seen neighborhoods that even aren't high-income neighborhoods really rally together and do those kinds of things that can improve their neighborhoods above and beyond what government is expected and has a responsibility to provide. Does that answer?
Partially answers. I guess the idea is that the budget's already there. We already all pay our taxes, and then it's just the use of that and allocation of that money comes through the crowdsourcing kind of web-based. People get to say where they want to go, and then part of that budget will be then directed towards that, towards funding some of those projects. So neighborhoods get to promote certain projects and then vote on where the money goes.
Sure, I think that would be interesting. You still have your elected officials make an ultimate decision, but if you had some way to present to them, these are the community's priorities, in a transparent way to see how they're actually allocating those funds, and then that would play into their elections next year.
Can I just respond to your? Just want to respond to the question. I live in San Francisco, and we've just had an interesting thing. Every district in San Francisco has been given $100,000, and we have been art. Some is to be used for art, some is to use specific improvement for transportation, and there's either you can vote in person or you can vote online and decide how the different sectors of the $100,000 per district are to be allocated. So it's a start. Yeah, is that sort of what you're aiming at? So at least one city's doing it, and probably New York and whatever will start doing things like that as well. But we need to go back to Zach. We need to be online. The citizens need to be informed and to be able to, actively participate in deciding how that money is to be spent.
Great, thank you. Jonathan, I think you.
I don't have a question. If there's any more questions, otherwise I would say we're running a bit behind, so we only have 5 minutes for lunch. No, we'll meet again in 40 minutes, 1 or 2.